Hi, my name is Matt Flannery, and I'm the Director of Geoscience and Engineering at Stratham Reservoir, and I would like to invite you to an upcoming seminar, Flow Assurance, Ensuring Economic Production, on May 14th at 11:30 a.m. Central Standard Time. I'll be reviewing why flow assurance can make your production more efficient and reduce your operating costs. Over the course of 45 minutes, I'll be covering the 5 main flow assurance challenges in the oil industry: wax, hydrates, asphaltenes, emulsions, and scale. I'll give you a brief introduction now. So wax. This is the same substance as we use for candles, for lubricating skis and waterproofing cars. Wax is dissolved in many oils, but it can deposit in pipelines or form high viscosity, non-Newtonian gels when it cools. In late field production, it can also deposit in wellbores or cause formation damage, especially for operations such as stripper wells. Other solids caused by cooling are gas hydrates. Now there are several types, but they can all form when water is mixed with gases commonly found in petroleum, usually methane, but also ethane and H2S as well. At high pressures, the gases stabilize the water crystals and they form ice-like solids at temperatures well above freezing. And they can cause problems in pipelines and in surface facilities, as you can see here. Next up is asphaltenes. Now this is a solubility class, as opposed to a chemical composition like waxes or hydrates. They tend to be less commonly problematic, but when they do occur, they can be a real headache for production operations, with deposits forming in the near wellbore, in the wellbore, pipelines and surface facilities alike. There are some dead oil screens, but the best way to screen for them is with high pressure microscopy using a representative sample, which is depressurized, and as you can see here in this time-lapse video, it allows us to determine the onset pressure fairly clearly, and this allows engineering decisions to be cost-effective in managing the issue. Related to asphaltenes are emulsions and foams. Now I say they're related because asphaltenes tend to stabilize colloidal dispersions. There is an expression that oil and water don't mix, but they actually do, and sometimes they mix too well. Stable emulsions can have higher viscosities than either the component oil or the water, and sometimes magnitudes, or rather, orders of magnitudes higher. They're usually formed in high shear environments or other restrictions in the production stream, and they can seriously impair surface facilities. You can see here the level of viscosity of this oil and water mix is a real issue. Water can cause problems alone in the form of scale. Now in the reservoir, water is at equilibrium with the minerals of the formation, which means that some of those minerals are dissolved in the water at those temperatures and pressures. During production, temperatures and pressures drop and the minerals are no longer in equilibrium. In addition to that, carbon dioxide can come out of solution, which reduces the acidity of the water, further reducing the solubility of the minerals. They then precipitate out onto any surface they contact. Now the biggest issue with these, or the biggest challenge rather, is that some of them are extremely stable. So stable in fact that they cannot be economically removed. The best option here is to assess the risk as early as possible and then manage it with chemical additives. Each of these is a discipline unto itself, but I'll be covering why they happen, how we can screen for them, and the main strategies to anticipate and mitigate them, so that the right decisions can be made for your asset. Please join me on Thursday at May 14th at 11:30 a.m. You can register on the Stratham Reservoir page on LinkedIn. I look forward to seeing you virtually then. Thanks, and be safe.